So another basic type of configuration that we want to consider is something called a voltage follower or a unity gain amplifier. We'll also hear this sometimes referred to as a buffer. And so looking at this circuit, we see it's different from the others that we've considered so far in that it doesn't have any resistors. And so if we look closely though, we can really see this is actually just a special case of our non-inverting configuration. So a special case of our non-inverting. And so it's a special case where we have one of two things, or both of them met, where we have our feedback resistor, RF, equal to 0, which is of course the same thing as having a short circuit. And so we can see that above the amplifier here, so we see where we're just connected with a wire as opposed to a resistor R sub F. Or we could have, switch back to my pen there, or we could say this is a special case where our R1 is equal to infinity. And so of course our R1 was the resistor we had here connecting to ground, but in this case we don't have anything, we just have an open circuit. So that would be like having an open circuit between our inverting terminal and ground. Or we could have both of these things be true. And so if we can consider the gain equation that we had for our non-inverting amplifier, we had that our closed loop gain is equal to 1 plus RF divided by R1. And if we consider either of these two cases or both together, what we'll see is that gain just reduces to 1. So 1 plus 0 is just 1. And so ultimately what that means then is that our output voltage is equal to AC times our input voltage. Well, if our AC is 0, our output voltage is simply equal to 1. And so at first glance, we say, what's the use of an amplifier configuration where our output is the same of the input? So why even bother? And the answer is a little beyond the scope of what we're going to look at in this particular class, but we find that this configuration has a high input impedance. And what this comes in handy when we're talking about multi-stage amplifiers, which we're going to look at a little later on. But whenever we have these multi-stage amplifiers, we have to worry about something called loading effects. And so again, we're going to touch on this more heavily in other classes, but this is kind of goes back to what I had talked about in a previous lecture, where if we have some output voltage, so maybe this is our output voltage from the first stage amplifier, and for a non-ideal op amp, we're going to have some non-zero output resistance. And then if we connect it to another amplifier stage, we're going to have some input resistance, Ri. So in doing so, we form this voltage divider. And so of course this is eventually going to close back and be referenced to ground. But by having this value of Ri be large, we can ensure that most of this voltage gets carried on to the next stage in our amplifier, as opposed to getting wasted on this output resistance R0. So we'll get into in later classes and a little bit more in later videos the purpose of this buffer, but for now it's just enough to know that it helps us mitigate loading effects, and our gain is just 1 or unity.